Hello everyone, welcome to 6.2 Matrix Operations. Alright, from 6.1 we learned how to write matrices and kind of why they're important as a way to organize your information. So we're kind of going to use this example to help us highlight how to use matrix operations correctly. So what I've done was I kind of made a matrix for this week, two types of vending machines, one for the students, one for the teachers. Alright, this is the teacher's lounge, this is for the students. And there's three types of drinks that are being sold. Fruit drinks, waters, and sports drinks. Alright, so 83, 65, and 98 were how many were sold of each one of those for the students, 33, 20, and 50 were for the teachers. That was for this week. Now someone also did the same thing for last week. They kept track of it. So now let's say you said, well, how many were sold for each vending machine total? Okay, so that's exactly what we're going to do. So what we are going to do is we are going to add matrices. This would be A plus B, right? Because I want to know how many were in both of them together, so I'm going to add them together. So what we are going to do is we are going to rewrite this and we're just going to add them together. So it's going to be 83, 65, 98, 33, 20, 50 in one matrix and a big plus sign, and then we're going to add the other one to that. So it's going to be 80, 65, 105, 25, 15, and 55. Alright, so if you think about this in terms of this problem, it kind of makes sense how we're going to add matrices, because what we're going to do is you want to be able to add the fruit drinks for the students to the fruit drinks from the students from last week. So we're going to add the 83 and the 80. We're going to add, let's use this right here. We're going to add the 83 and the 80 first. Okay, so 83 and 80, 163. So that's how many fruit drinks were sold to the students or bought by the students in total. All right, then what we're going to do is you're just going to work our way either down or across. It doesn't matter the order in which you do this. So whichever way makes sense to you. 33, 25 is going to be 58. All right, then we have 65 and 65 again is 130. Then we're going to do the next one. 20 and 15 is 35. And then I will do the next one. 98 and 105 is 203. Okay, and the last one that we have is 50 and 55 is 105. All right, I did a lot of different colors here to kind of highlight how this works. And we would put it inside that bracket to make sure that it is a matrix. So that we would know this first one is how many fruit drinks were sold to the students in both weeks. I would know where all of these come from and what they all mean. Alright, so that's kind of some context for how matrix addition works. Alright, so here's example A. Here's something that we're going to work on. This matrix represents a triangle. 3, 2, 1, 3, 2, and negative 2. Here's what we're going to have to do first. Graph the triangle and its image after a translation left 3 units. Write a matrix equation to represent this transformation. Alright, so first, if you know that all points, if we're going to graph it, are x and y, which means we have 2, it doesn't make sense to have it go this way. So we're going to have to write x this way and y this way. So these are the x points, these are the y points, and this would be like point 1, this would be point 2, or point 3. You can also label them like we do in geometry, A, B, C. Alright, so what I have done over here is actually I already graphed it. So if you see right here in black is the graph. Okay, and then it said a transformation left 3 units. So what I did was I moved each point left 3, and I put it in red, left 3. For this one, put it in red, left 3, put this one in red, and then this one's dashed because it kind of covered up the black ones and I didn't want to get it too confused. Alright, so we have all of them here. The original black and then left 3 units in red. So now what we're going to try to do is we are going to write a matrix equation to represent this transformation. So what we have to do first is we're going to have to take our original matrix, negative 3, 2, okay, 1, 3, and 2, negative 2. Alright, and if we are moving it left 3 units right here, I'm moving it left 3, how am I changing the graph? Am I changing the x's or the y's? Yes, you are right. We're changing the x's. We're not changing the y's. We're not going up or down. We're only going left or right. So that means if we could say if we're moving to left, left means going this way, right? We're going this way. So that means we are going to be subtracting 3 from the x's. So we could do minus And in this matrix, it's going to be minus 3, minus 3, minus 3. Hold on, I'm getting a phone call here. Hold on 1 second. All right, I'm back. Sorry about that, everyone. My sister calls, and I had to answer and talk to her. So, where we were at was we had this matrix. We were moving over from this spot to this spot. We were moving the x's minus 3, moving them to the left. Oh, move them to the left. I'll figure it out. And we're not moving any up or down, so the zeros are going to be here because we don't want to change those y values. We want to keep them just like they are. So if we add zeros there, that'll be just fine. Okay, so that means our new matrix is going to be negative 3 minus 3, negative 6. 1 minus 3, negative 2. And 2 minus 3 is negative 1. These all stay the same. 2, 3, negative 2. All right. And if we just go back here and check this real quick, let's make it nice and big. So let's make the other one nice and big so we can see it. And are those coordinates for the x negative 6, 2? So if I go to negative 6, 2, yes it is. And the next one is negative 2, 3. I go negative 2 up to 3. That works out. And the last one is negative 1, negative 2. So right there, it's perfect. So we did the matrix correct. All right, so let's just move that back here. Let's move this. Oops, let's move this over here. And where did I go?